My name is Bjarke Poulsen. I am one of the two co-owners of M&W JAWO Sampling. We are one of the world's leading engineering companies in providing solutions, machines and instruments for taking representative samples of solids or bulk materials in virtually any kind of shape, from very big piece of coal or ore to extremely fine powders. We've been doing this for close to 50 years now, and material reduction is a very important part of the sampling process. And therefore we have over the last number of decades developed different kinds and variants of crushers and shredders for reduction of material in the sampling process. And they can be used either in the primary or the secondary or the tertiary part of the sampling process, if you have that many, and also come in smaller versions, reduced versions for laboratory purposes. Now I'll be demonstrating the jaw crusher, which you see behind me. The jaw crusher is very good for abrasive, very hard material, can also be slightly moist depending on the particle size, but it's really not good for sticky materials, which I'll show you later why. Here you see the jaw crusher. This particular variant has been constructed and engineered where we have included a larger frame than normal. We've included an inlet hopper in combination with a sieve. If you look further down, the purpose of this particular construction is that this jaw crusher is then able to handle very large quantities of materials coming down, for example, during a very small period of time. It could be emptying a big bag, it could be underneath a chute or a duct where lumps are coming non-continuously. So the sieve, the purpose of the sieve is here, it will slowly vibrate. There's a vibration motor on the other side. It will vibrate the material down into the crushing chamber. The section below the hopper and the sieve comes with an inspection lid, which is very easy to open, as you can see, and if you'd like, you can then inspect the crushing process whilst in operation. Two hatches closes this and makes this completely tight, so no dust. If you want to clean or replace the crushing jaws here in the crushing chamber, it's very easy. You simply open up, and as you can see here, then you see the moving jaw, also known as a pitman, and the permanently placed jaw. And so the pitman is crushing the material like this, and in this case the two jaws, they are made in manganese steel. We also supply them in, for example, stainless steel or carbon tungsten and other materials. When you want to change or alter the crushing ratio, you do it here. As you can see, it's very nicely made. You just simply open. If you want the output size to be smaller, you move the jaws closer to each other like this. If you want the material output to be larger, so the crushing ratio is smaller, you move the arm over here as follows. So enough theory and now practice. I will now be demonstrating the crushing abilities of the jaw crusher behind me. Actually, I haven't tested it on these materials, this particular version that is, apart from the iron pellets which you see here, which are relatively dry. They have a moisture content of between 2 and 4%. Between 5 and 15 millimeters particle size. In fact, I think some of them are a little bit larger. And then we'll be moving over to some slightly lumpy polysilicon, granular polysilicon. And thereafter copper concentrate in a more lumpy form. moving up the ladder of difficulty to iron sinter, as you can see here. We'll also be demonstrating the crushing of ferrochrome and the quartz which I have here. And then finally, what I really look forward to, these are the exact same iron pellets as you have over here. The only difference is that these iron pellets, they contain a moisture content of approximately 20%. And in fact, I don't think it will work. I think it will turn into a mesh, a kind of a mud, which won't kind of really go through the breaking jaws, but we shall see. In any event, even if it works, remember jaw crushers and wet material, in particular very wet and sticky material, is a no-go. Okay, so I'll now be turning on the jaw crusher, the reason being that it needs to get up in full momentum before I start crushing. I will be putting the material down the inlet hopper and the sieve. It will go down into the crushing chamber where the two breaking jaws down here are operating. And finally, you should be able to see it going into the box here, or the jar in the box. I'll now be crushing the iron pellets, the dry version, 2 to 4% moisture content. And the result of the crushed iron pellets, you can see here, relatively small particle size. I don't know how many millimeters, but no, certainly not many. And that was also because I put the crushing ratio up to 3/4 size approximately. And now I'll be crushing the finer materials, the more lumpy polysilicon in this case, as well as the copper concentrate in this case. For that, naturally, I need my crushing to be even finer and tighter, so I'll move my crushing arm, just make sure the two jaw plates don't touch each other. That's really bad, but you can get it up to here, for example. And in the case of the copper concentrate, it's really bad for breathing, so I'll just take my precautions. And the polysilicon is really bad for the eyes, so that's also why I'm wearing glasses, safety glasses, just in case. And hopefully what we should see is a significant reduction of the lumps in the polysilicon. So here you have the crushed sample, and here you have the pre-crushed sample. And again, you will see extremely fine copper concentrate. Here, try to compare it with the pre-crushed, more lumpy version here. It's exactly the same material. And now iron sinter between 10 and 50 millimeters. I think most of it is actually around 50 millimeters. And as you can see, quite a big difference. Not surprising also. First of all, I had the crushing ratio up pretty high, and also iron sinter is very brittle and easy to crush actually. So there you see the result. I will also show you what happens in the crushing chamber while we crush, which you can see here. An inspection, it is very easy, opening up. Actually, instead of putting it from the sieve, I'll be putting it directly into the chamber. And now we move up the ladder in terms of hardness. Here we have the ferrochrome. And as you can see, a jaw crusher loves hard material even as ferrochrome. And then we'll do the quartz. I'll take the smaller pieces, as this is engineered up to 90 millimeter of material inlet size. So quartz here 50-60 millimeters. And now what I've been looking for, moist iron pellets, 20% moisture. Let's see if it can handle it. Let's see what happens down in the jaw crushers and wet material, in particular very wet and sticky material, is a no-go.